We are going to look at parabolas today, and to be successful, you should already know a lot about parabolas whenever they are defined as a function of x. So that's whenever they are solved for y and we have our x is squared over here. So particularly with vertex form, we can think of it like our parabola is moved to the right h units. It is moved up k units. It has a vertical stretch or shrink of a factor of a. Those sort of things we should be familiar with. What you're probably less familiar with is what the parabola looks like whenever it's defined as a function of y. So in this case, you have an x equals and your y is what's squared. So we will be looking at these as well. These are going to be parabolas that are turned on their side like so. So let's look at a few features. First of all, a parabola that's going to open upwards or downwards, these are the ones that you're most familiar with probably. They are going to be y equals equations. If they open left or right, they're going to be x equals equations. And so for all of these, you're going to see this letter P, or for some of these things, you'll see this letter P used. And to find P for either one of these, we would be looking here at 1 over 4a, with a being this number right here. And so to find the vertex, it's just going to be hk, opposite sign here. Do not use the opposite sign here. Notice over here, this is the h and k are switched because here you have the y on the inside, so that k is that y coordinate here. We're going to have a focus of a parabola, and that focus is going to be a point on the inside of the parabola, like here or here. Similar to our focus with our ellipse, although parabola is going to be defined slightly differently. We will have an axis of symmetry. So, of course, that's going to be a vertical line whenever we're talking about these, and it's going to be a horizontal line whenever we talk about the ones that open left and right. There is going to be a line called a directrix, and I'll show you a little bit more about that here. So that line that's a directrix is going to be on the outside of the parabola, and it's not actually going to touch the parabola. So here, that would be a horizontal line. Over here, it would be a vertical line, and we're going to look at that a little more in a second. And then, of course, we should already know that if this a value here is positive, that our parabola will open upward. It'll be a happy face parabola, and it will open downward if that's a negative. For the left and right parabola, right is your positive direction. So if a is greater than 0, your parabola will open to the right over here. If it is less than 0, it opens to the left. So let's look first at what a parabola is defined as. So I've got this Desmos graph that I have made here so you guys can kind of see what we're dealing with. And let's put these side by side so that we can see the definition next to what it is called here. So a parabola is defined as the set of points equidistant from a point and a line. The point is called the focus. That's this red point on the inside of this graph right here. And the line is called the directrix. That's this blue line right here. And so you can see, as I look at the points on this parabola, these red dotted lines are always the same length. So the distance from the point to here and then the line to here are the same. Notice that's a perpendicular distance. And so if you have all of the points the same distance from a point and a line, it forms this parabolic shape right here. And so that is the official definition of a parabola, and that is why we are learning how to find the focus and the directrix. Because if we knew maybe these points that we needed for something, we could develop a parabola that we needed. So let's look at what this is going to look like as far as finding vertex, focus, directrix, and axis of symmetry. Remember, some of what you're going to have is going to be non-calculator active on this next test. So You have to be able to do this without using Desmos, which might be a little much to ask for some of us, but I think you guys can do it. So for this particular parabola, notice that we have this x equals here. And so x equals means that we're dealing with a parabola that opens to the right or to the left. You don't have to graph these, but I do suggest that you sketch like a simple graph. So here we have a positive 2, which tells me that this parabola is going to open to the right. Now, let's start by finding our vertex. And so our vertex, we've got to be really careful with here, because I want to look at this and say that it's 4, 3, but notice this is our y on the inside because we're dealing with a parabola that opens to the right. So that means that this is going to be our y coordinate, and because it's inside of the parentheses, we're going to go in the opposite direction. So we're going to have a negative 4, we're going to get a positive 4 for our y coordinate. So inside of the parentheses means use the opposite sign. Because it's with the y, it has to be our y coordinate. Now, that means that this 3 out here, instead of moving it the parabola up or down like it would if this was a y equals parabola, this is going to move the graph to the right or left, and it's going to be to the right 3 in this particular case. Because this is not inside of the parentheses, you just use the same sign that you have here. So the vertex is really important to find first because that is going to give you a starting point for everything else. So in order to find the focus, the directrix, well, actually we could do axis of symmetry now, but let's do focus and directrix first. We need to know that focal length. So that's our P value, and it's always 1 over 4A. So our A for this is the value right here. So our focal length here is going to be 1 over 4 times 2, which will give us 1/8. So that means to get to the focus, I would go to the right 1/8. And to get to the directrix, which is going to be this vertical line out here, I would go to the left 1/8. So if we want to give the coordinates of the point for the focus, I'm starting at the point 3, 4, and I'm moving to the right 1/8. So that means my x-coordinate is I'm going to add 1/8 to my x-coordinate. So it's going to be 3 and 1/8, 4. I don't normally use mixed numbers, but I will here just so I don't have to deal with those fractions. So 3 and 1/8, 4 is going to be our focus. For our directrix, we have a vertical line here, and that vertical line is going to have an equation that's x equals. Remember, x equals is vertical, y equals, that's horizontal. Okay, so my x-coordinate here, I'm at 3. When I'm right here at the vertex, I'm going to have to go to the left 1/8, which means I'm going to have to subtract 1/8. So I'm going to get 2 and 7/8 for my directrix. And then the axis of symmetry is going to be this line that goes through the vertex here that splits that parabola in half. Because this is a horizontal line, we'll just call it AOS for axis of symmetry. Since that's a horizontal line, that is going to be a y equals line. And the y-coordinate right here is the same as the y-coordinate of your vertex, which is 4. So you have y equals 4 for your axis of symmetry. Okay, this next problem that we're going to look at is not in vertex form. So we're going to have to put this equation in vertex form. It's going to be a little bit different than it is with our circles and ellipses and hyperbolas. So the main difference is that we only have one side of the function that we're really going to work on, because parabolas only have an x squared rather than having an x and a y squared. So we want to factor out the 2 right here. So we'll have x squared minus 4x. And I'm going to go ahead and put a plus blank right here. And I'm going to put my plus 5 over here on the end. I'm just going to kind of leave it there. Now, typically, with our other problems, we have just been taking this number right here and we add it to both sides. But another way that we can do this, if I add a number here, but then I also subtract the equivalent number, that's also going to balance each other out, because if we add 5 and subtract 5, or add 10 and subtract 10, then we haven't actually changed the value of that side of the equation. So this is the way that we're going to do these problems. So you will complete the square, just like we've been doing for all these other problems. So 4 divided by 2 is 2, so we got x minus 2 squared. And then 2 squared is 4, so 4 is the number that goes right here in this blank. So we've got the 4 here. We are not going to subtract the 4, but rather we need to subtract an 8 here, because we have to take that 2 and multiply it by the 4 that we see here, which gives us 8 right here, because that 2 would be distributed in this case. So I've got a plus 5 and a minus 8, which is going to give me a minus 3 right here. I'm just going to bring that 2 right down, and y is going to equal 2 times x minus 2 squared minus 3. So I've got this in vertex form. So now I can tell that my vertex in this case, actually, before we do vertex, I'm going to sketch a little graph here. This one is going to be a parabola that opens upward, because I know it's a y equals, which tells me that the parabola opens up or down. And because this 2 right here is positive, I know it opens upward. So my vertex here is going to be at positive 2, negative 3. So I've got that positive 2. I use the opposite sign here because that's inside of the parentheses. It's going to be the x-coordinate because we have the x here. And then this other number is my y-coordinate. So this vertex here is at 2, negative 3. For the focus in the directrix, I need that focal length. I need that p-value, which again is 1 over 4a. And I probably should have picked something that wasn't the same as the last problem, but we've got a 2 here, so it's 1 over 4 times 2, which of course is 1/8. So we've got that same focal length, which means we're going to go up 1/8 and down 1/8 to get to our focus, and then of course our directrix here. So for the focus, our starting point is that vertex point. We're going up 1/8. So that y-coordinate is going to change here because we're going up or down. So I've got negative 3. I'm going to go up 1/8. So my x-coordinate will stay the same, and I'll get negative 2 7/8 for my y-coordinate. It looks like I subtracted there, but we're in the negative, so I actually added 1/8 there. For the directrix, for this one, I've got a horizontal line. Horizontal line is always a y equals equation. And so your y-coordinate of your vertex is negative 3. If you go down 1/8, you would have to subtract 1/8 from that y-coordinate, and you would get negative 3 1/8 here. So that's going to be the equation of your directrix. And then the last thing that you need is your axis of symmetry. So we're looking for the equation of this line that cuts that parabola right there in half. It is a vertical line. Vertical lines are always x equals equations, and the x-coordinate of that vertex is 2. So that would be our axis of symmetry, x equals 2. Let's move on. Here is another problem where we've got to find the vertex, focus, directrix, and axis of symmetry, and this one is not in standard form. So for this one, we've got x equals y squared minus 12y. And I'm going to go ahead and group these two together and put my plus blank. The 4 I'm going to leave over here. If I add a plus blank here, I'm going to need to subtract the plus blank outside of the parentheses. So we're completing our square just like we've been doing on our other problems. 12 divided by 2 is going to get us 6. 6 squared gives us 36, so that's what we're going to put in the blank right here. And so if I add 36 here, I must subtract 36 on the outside. I do not have a number in front of my parentheses here, so I don't have anything to multiply that by. So positive 4 and negative 36 is going to give me a negative 32. And so this is the equation of my parabola. Notice this parabola is a x equals. I don't have a number here. I could put a 1 there if I want, but it's positive. So this is going to open to the right. And my vertex for this, remember to be very careful with your vertex. I've got the 6 right here, but it goes with my y. So 6 is my y coordinate. Use the opposite sign because it's inside of the parentheses. The y is here, so it's my y coordinate. This other number, this negative 32, that is my x coordinate. So my vertex here is at negative 32, 6. From here, I need that p-value, which is 1 over 4a, which in this case is just 1 over 4 times 1. So 1/4 is my p-value here. So for my directrix, oh wait, let's do focus first. We are going to go to the right. Since I'm going to the right, that's changing that x coordinate, and it's going to add 1/4 to it, which is going to give me negative 31 3/4. 6. That y coordinate does not change. The directrix is going to be over here, and it is going to be a vertical line, which means it's going to be x equals. So my x coordinate, I'm subtracting 1/4. So I'll get negative 32 1/4 here for my directrix. That's an x equals line. And then the axis of symmetry, it is going to be horizontal, which is a y equals. And the y coordinate of that vertex is 6. So it's going to be y equals 6 for the axis of symmetry. Okay. For example 4, I've got y squared equals negative 4 times x minus 3. And I'm supposed to write this in vertex form and find the vertex, focus, directrix, and axis of symmetry. So I've got y squared equals negative 4 times x minus 3. And so this one, it kind of seems like I should just, like it's already a y equals, but that's not the case. My y is the one squared here, so I need to solve this for x. So there's a few ways you could solve this for x. I would distribute here first. So I'd get y squared equals negative 4x plus 12. Then you could subtract your 12. So you got y squared minus 12 equals negative 4x. And then you could divide by that negative 4. And so you would get, right here, there's a 1 right here, so you could write this as negative 1/4 y squared plus 3 equals x. And actually, I like writing the x on that left-hand side, so let's do this. Now, you don't have to put this into vertex form past this because you don't have a y coordinate, so you don't have to complete the square here. What you've actually got for this one, it's like you've got a y plus 0 squared plus 3 here, so this is essentially already in vertex form. So for our vertex, we would have a y coordinate of 0 and an x coordinate of 3. In this problem, we've got x equals a negative 1/4. It's an x equals, which tells me that this is going to open to the left or to the right. Because my 1/4 is negative, it's going to open to the left. this time. And right here, of course, our vertex is at 3, 0. Now, before we can find our other parts, we need to know that p-value, which is 1 over 4a. In this case, that's 1 over 4 times 1/4. I'm leaving that negative off here and just going with the value. The reason that I'm doing that is because I'm relying on my picture to tell me whether I need to move to the left or the right. So I just need to know that distance. And so my focus is going to be 1 to the left, and my directrix here is going to be 1 unit to the right. So for the focus,
at this time, all bus riders are dismissed to the bus lot. Thank you.
For the focus, we need to move to the left one, which is going to change the x-coordinate. When you move left or right, it changes the x-coordinate. So we need to subtract 1 from that 3, so we would get 2, 0. Those would be our coordinates of our focus. Our directrix is a vertical line, which means we're going to have x equals, and then right here at the vertex, your x-coordinate is 3. If you move to the right one, your x-coordinate there will be 4. So we will have a directrix of x equals 4. And then the axis of symmetry goes right down here through the middle. This is a y equals line because it is horizontal, and your y-coordinate is 0. So it's going to be y equals 0 for your axis of symmetry. So for this next problem, I've thrown this in because we've got something a little bit different that's going to happen here, so pay close attention. We want to solve this equation right here for x. So the first thing we need to do is move that 3y squared over to the other side. So we'll have negative 8x equals negative 3y squared. I'm going to put the plus 12x first and then the plus 30. So the problem that we're running into here is negative 8 does not go into all of these terms. And so if you divide everything by negative 8, you're going to have all these fractions that you have to deal with. So in order to avoid that, let's not divide everything by 8 and go ahead and do our completing the square. So we're just going to leave this negative 8 over here to the side first, and we are going to complete the square on this right-hand side. So we need to factor a negative 3 out of this set of parentheses. You cannot do completing the square when you have a number in front of your y squared, so we're just going to factor that out. And so we'll get y squared minus 4. Oh, I'm sorry, this is a typo in the problem. This needs to be a y right here. So let's do a y plus blank, and then we put plus 30 minus blank here. So we're going to complete the square. This negative 8x just hangs out over here. Negative 3 stays out front. We're going to have y. If we do 4 divided by 2, we're going to get a 2 here. When we square that 2, we'll get a 4. But remember, we've got to multiply the 4 by this number out front. So 4 times negative 3 is going to give us a negative 12. And if we have minus negative 12, that becomes a positive. So 30 plus 12 is going to give us 42. And so whenever we do this here, now we have completed the square. Now we can deal with this negative 8. So we're going to divide the left-hand side by negative 8. When you do this on the right-hand side, each term is separated by the plus or minus sign. So this whole thing right here is one term, and then you got that 42 is the other term. Both of those must be divided by the negative 8. And so we're going to get x equals, here the negative 3 and the negative 8, we cannot really reduce them, but we could do, since we have a negative over negative, we could make that a positive 3/8 times y minus 2 squared. And then 42 over 8 does not go evenly, but we could reduce it into a negative 21 over 4. So we kind of get a fraction there. It's a little bit ugly, but it's not too awful to deal with. So we have a vertex for this parabola at our y coordinate is going to be a positive 2. our x-coordinate is that negative 21 over 4. It might even be helpful in this to change that to a decimal. So if you change that to a decimal, you got negative 5.25. And 2, it might be a little bit easier to work with. For your focus and directrix, first of all, we need to know which way this opens. We have a positive A value here, so this is going to open to the right. We got that vertex right there at negative 5.252. And we need to know that P value, which is 1 over 4A, which is going to be 1 over 4 times 3/8 for this problem. And so that's 1 over, that 4 is like 4 over 1, so it's 1 over 12/8. Dividing fractions is easy as pie. Flip the second and multiply. So 1 times 8 over 12. This is just 8 over 12. Of course, 8 over 12 will reduce. You could divide both of those by 4, and you'll get 2/3, or 0.6 repeating. So I made a problem that gives a little bit ugly answers here. So to find our focus, we need to go to the right 0.6 repeating. Because these answers are a little bit ugly, I'm going to grab the calculator for this. I won't give you one on the calculator inactive problem where you've got to add something quite this bad as far as the fractions go. So my x-coordinate is negative 5.25, so I'm going to be doing negative 5.25 plus the 2/3, and so negative 5.25 plus my 2/3 is going to give me negative 4.583 repeating for my x-coordinate. How about 2 for my y-coordinate? The directrix over here for it, I'm going to have to do the negative 5.25 minus the 2/3. And so whenever I do that, I'm just going to use the calculator because I've made a problem that has kind of ugly answers here. I get negative 5.19667, so my directrix is going to be at x equals, and it's going to be negative 5.916 repeating there. And last, that axis of symmetry is going to be horizontal. So whenever we have that horizontal axis of symmetry, we have a y equals, and the y value of my vertex is 2, so it's going to be y equals 2 for that one. And I'm actually not going to do this last example. So your assignment is from page 659 in the textbook. I have put a picture of that in Canvas so you can see that there, because I'm not going to actually pass out the textbooks. And we're going to do 13 through 21. Please do not graph these, well, you're not required to graph them. I would suggest doing a rough sketch of the graph like I have been doing for these problems, but you do not have to actually graph them. All of this is going to be calculator inactive, so do try to do these without a calculator. You're welcome to use Desmos to check your answers.